Good evening to all. I am Dr. N. Siluraj, Associate Professor in the Department of Bioscience and Bioengineering at IIT Guwahati. With extensive experience in environmental sustainability, my research is focused on the innovative solutions for waste management and wastewater management in urban ecosystem. It's honor to present here as a part of a ATAL FDP 6 days faculty development program on waste management solution for sustainable cities and sustainable water management smart cities. This FDPs aim to equip our participation with advanced knowledge in waste management. By integrating the principle of circular economy, smart technologies, and sustainable practices, we will explore solutions that contribute to smarter, greener cities. Together, let to adopt eco-friendly practices. First, we know about what is the waste management and what are the importance of the waste management. Waste management refers to the systematic handling of waste materials, including their collections, transportation, treatment, recycling, and the disposal. It aims to minimize the adverse effects of waste on human health, the environment, and urban aesthetics. The proper waste management prevents pollutions, conserves resources, and reduces the strain on landfills. It plays a crucial role in mitigating the climate changes by reducing greenhouse gas emissions from untreated wastes. Effective waste management supports a circular economy, turn waste into the valuable resources. In urban areas, it ensures a cleaner and healthier living environment. It also fosters sustainable development by promoting responsible consumption and production. We know for the current global waste statistics, nowadays globally approximately 2 billion tons of municipal waste, solid waste, waste are generated each year, with the projections showing an increase to 3.88 billion tons by 2050. Due to a rapid urbanization and population growth, shockingly, over 33% of waste is not managed in a environmentally sound manner. Plastic waste exceeds 300 million tons annually, with only 9% recycled, while the rest of end up in landfills or in oceans, contributing to environmental pollution. Food waste is another major issue, with 1.3 billion tons wasted annually, equivalent to third of all food product produced, 1/3 of food produced. And greenhouse emissions are also produced. E-waste, which contains hazardous materials, is growing at the rate of 50 million tons per year, with only 20% is recycled properly. In low-income countries, like African countries, waste collection rates are low as 39%, leading to widespread dumping and environmental degradation. Landfills remains the most common disposal method, causing methane emission and groundwater contamination. Additionally, high-income countries produce 30% of world waste, despite the making up to 16% of population. The statistics underscore the urgent need for effective waste management system, public awareness, and global cooperation to tackle these growing crises. What are the challenges faced by urban area? Urban areas face significant challenges in managing waste due to rapid population growth. urbanization, and increase in consumption. The lack of proper waste segregation at the source of leads to insufficient recycling and landfill overuse. Inadequate infrastructure for waste collection and disposal, environmental pollution, including air, water, and soil contamination. The rising generation of plastic, e-waste, and hazardous waste poses additional threats to the public health and ecosystem. Informal waste management system in many cities resulted in unregulated dumping and burning. Only the limited awareness and participants by our city people hidden the sustainable waste practices. Financial constraints often delay the adaptation of modern waste management technology. The challenges demand innovative, inclusive, and sustainable solution to ensure urban resilience. Next, introduction to the waste hierarchy: reduce, reuse, and recycle. The waste hierarchy is a framework that priority strategy to minimize waste and environmental impact. It consists of three main keys: reduce, reuse, and recycle. The first step is reduce, focuses on minimize the waste generation by optimizing consumption, choosing the sustainable products, and reducing packages. Reuse emphasizes the finding new use of item, extending their life cycle before the disposal. The principle encourages practices like donating, repurposing, or repairing. Finally, recycle involves converting the waste into new material to reduce the need for raw resources and low energy consumption. By the following hierarchy, we can conserve resources, reduce landfill waste, and promote sustainability. The hierarchy encourages a shift from traditional take, make, and dispose, or a model to more sustainable circular economy. Nowadays, we are in a target of waste to wealth. Is the main target of all the people. Next, what is circular economy? So the concept, the basic concept of circular economy. A circular economy is a system where produced and material are reused, recycled, and repurposed instead of being thrown away. Unlike traditional take, make, dispose model, it focuses on keeping resources in use as long as possible. The goal is to reduce waste, save resources, and minimize environmental harm. In the system, products are designed to easily repaired or recycled. It encourages business to use sustainable material and create products that last longer. Reusing and recycling reduce the need for new raw material and lower pollution. A circular economy helps to reduce landfill waste and conserve natural resources. It also creates a new job in recycling and sustainable industries. This approach leads to more sustainable and eco-friendly economy. Ultimately, it helps to preserve environment for future generation. Next, what is the benefits of circular economics for a city? A circular economy offers numerous benefits for the cities, primarily by reducing the waste and conserving the valuable resources. By promoting recycle or reuse and repurposing a material, cities can be significantly lower the amount of waste sent to landfill. They help to conserve the natural resources, reduce the needs for raw material, and cut down on the pollution. Additionally, the circular economic boosts economic growth by creating new industries and job opportunities in like recycling and repair. Moreover, the approaches fosters a sustainable urban development and increase the resilience to the resource shortages. Overall, the circular economy helps to create cleaner, healthier, and more sustainable cities, improve the quality of resistance. Okay, we go for one case study. In our India, in the Indore is the cleanest city, Indore is the cleanest city in India. Is a prime example of successful waste management through circular economic principle. The city implemented an efficient waste segregation system, ensuring the waste is separated at the source into wet and dry and hazardous category. This has significantly reduced the amount of waste sent to landfill, indoor waste to energy plants, convert the organic waste into biogas and compost, providing the both energy and valuable fertilizer. The city also promotes the recycling of dry waste with material recovery facilities in a place to recover and process recyclable. Indoor is zero waste model encourage the resistance to adapt the sustainable practices by separating the waste at home and utilizes decentralized waste processing. A city efficient door-to-door collection system ensure that the waste is segregated properly before being sent to the processing unit. Moreover, the city has been focusing on the reuse of construction and demolition waste by recycling it into the construction material. Indoor is leadership in promoting the circular economy in our India has attracted attention from the various cities, making it a role model for sustainable waste management practices. The cities also organizing awareness campaign to educate the cities about the waste reduction, composting, and recycling. In 2017, Indore was declared as the cleanest city in India under the Swachh Bharat system. Further, highlighting the impact of circular economic efforts. Indoor approach is not only address the environmental challenges of waste management, but also create economic opportunities through the green jobs. The cities has made impressive strategies for urban planning and development. Indoor focus on waste resources technology has significantly reduced in carbon footprint, demonstrating the potential of circular economic models in smart cities. Okay, before going that, we know the what is smart city. A lot of the people think the smart city is in urban area that uses the digital technologies, data, and interconnected system to enhance the quality of life for its residents, improve the efficiency of services, and promote sustainability by integrating the advanced information and communication technology (ICT). Smart cities aim to optimize the infrastructure, transportation, and energy, waste management, and public sectors. In India, the smart city mission include 100 cities aim to improve the urban infrastructure, sustainability, and quality life through technology. Notable cities include Pune, Jaipur, Surat, Bhubaneswar, and Chennai, Kochi. The player missions. They are the main cities of playing the missions. Together, they represent a model for sustainable and inclusive urban development in India. Next, why a need for a smart city, smart waste management in smart city? As cities grows, the amount of waste they produce also increases, making it harder to manage effectively. Traditional waste system management system often face problem like overflowing bins, insufficient collection, and pollution. Smart waste management uses technology like sensor, IoT, and data and data to make a waste management more efficient and sustainable. Okay, what are the challenges management in waste management in urban cities? Waste management in urban areas focus numerous challenges due to increasing waste generation and limited infrastructure. One of the primary issues is high waste generation, driven by the population growth and consumption patterns and urbanization. The inadequate infrastructure for collection, transportation, and the processing of waste further complicate the situation, with many cities lacking insufficient waste processing plants or recycling facilities. Limited landfill space is also another concern, as most cities struggle to find new sites for waste disposal, leading to overflowing landfills and environmental hazards. The segregation and recycling of waste are also significant challenges, as many people do not separate recycled material for unrecyclable, making it harder to recover valuable resources. Additionally, the rise in hazardous and electronic waste presents a unique challenges of the material require special handling to prevent health risks and environmental damage. The, the pollution and environmental impact caused by the improper waste disposal, including toxic leaks from landfills and air pollution for burning waste, affect both the ecosystem and public health. Moreover, high operation costs associated with the waste collection and transportation and disposal put a financial strain on the cities, especially those limited budgets. Illegal dumping and littering for the acceptable the situation as waste often disposed in unauthorized areas, leading to pollution and high risk. Public awareness and participation in waste management practices remain low in many cities. Effective waste reduction and recycling efforts. Finally, a rapid urbanization and population growth continue to outpace waste management solution. While the increasing effect of climate change add a pressure on the cities to find sustainable long-term solution to waste management. These challenges demand innovative, coordinated efforts of ensure the cleaner, more sustainable and urban environment. Next, what is the use of artificial intelligence in waste management? What are the applications of AI in waste management? AI playing an important role in waste management for smart city, making the process more efficient, sustainable, and data-driven. AI-powered system can optimize the waste collection routes and analyzing data from the sensor placed in a smart bins, ensuring time pickups and reducing fuel consumption. By predicting the waste generation patterns, AI helps cities to manage resources more effectively, reduce operational costs. Smart sensor in bins can be detect the fill levels, enabling the waste to be collected only when necessary, reducing the unnecessary trips and preventing overflows. AI can also engage the waste sorting by using machine learning algorithm to identify and separate the different types of waste, improving recycling efficiency and reducing contamination. Additionally, AI can be applied in waste to energy technology, where it helps monitor and control the conservation of waste to energy, ensuring the optimal energy production. AI algorithm can also assist in identifying the illegal dumping by analyzing the data from surveillance camera and sensor network and enabling the quicker response from authorities. Through data analytics, AI provides cities with valuable insight into the waste generation trends, helping policymakers make informed decisions. AI system can also improve the public engagement, offering personalized recommendation for waste reduction and recycling. By integrating AI into waste management system, smart cities can not only increase the operational efficiency, but also contribute to the environmental sustainability and circular economy. Furthermore, AI can predict and mitigate the environmental impacts of waste disposal, such as greenhouse gas emission from landfills. The use of AI in the waste management is a crucial step towards the creating smarter, greener cities with reduced waste and improved resource utilization. Next, we know about the waste to energy initiatives. We know the biomass. The biomass is nothing but is organic waste made from the plant waste and other animal waste. The collection of waste is the biomass. So we do the two process: thermal conservation, bioconservation, mechanical conservation. The waste to energy initiatives are promising solution for managing waste while generating the renewable energy, addressing the two critical urban challenges: waste disposal and energy production. With growing population and increasing waste generation, Our waste to energy offers sustainable way to reduce the landfill waste while providing alternative energy resources. The process involves converting the non-recyclable waste into the useful energy form, such as electricity, heat, or biogas, through the energy conservation methods. The technology not only reduces the volume of waste, but also they help to conserve resources and lower dependencies on fossil fuels. The combustion are the most widely method used in the waste energy conversion method, where waste is burned at high temperature to produce heat, which then converted to the electricity or directly use the heat. This process significantly reduces the waste volume while generating the energy. And also, yeah, if you have a biological waste like anaerobic digestion focuses on organic waste such as food and agricultural waste, which is broken down by anaerobic bacteria in an oxygen-free environment without oxygen to produce biogas. This biogas can be used for energy generation, making anaerobic digestion an eco-friendly option with the minimum environmental impact. Is another one is gasification. On another hand, we convert the waste into synthetic gas by heating with a low oxygen environment, which can then transport into the electricity, heat, or liquid fuels compared to the increasation. The gasification is the more efficient and produces fewer emission. Another significant in the waste to energy process, gas recovery, where the methane generated from the decomposing waste in landfills is captured and converted into electricity, reducing the greenhouse gas emission and preventing the pollutions. Biomass power plants also contribute to waste-free energy by using organic material such as wood, agriculture residents, and energy crops to produce energy, promoting sustainability while addressing the waste issue. The benefits of waste to energy are numerous. The reduce the volume of waste sent to landfills and reducing the environmental and space-related challenges by the landfill expansion. It also produces renewable energy, reducing reliance on fossil fuels, contributing energy security. By capturing methane from the landfills and reducing waste, these initiatives help to mitigate the climate change by lowering the carbon emission. Moreover, they create the green jobs in the energy and waste management sector, stimulating the local economic and promoting sustainable development. As cities thrive from the circular economy, the waste to energy plays a main role in the transporting waste into the valuable resources, supporting cleaner, smarter, and more sustainable urban environment. Next, how AI support the waste to energy initiative? It's enhancing the efficiency and sustainability of waste to energy initiate by optimizing the various stages of waste management energy process. AI helps to improve waste sorting and segregation by using machine learning algorithm and sensor automatically identify and separate the recycling material from non-recyclable, ensuring the better quality waste and reducing the contamination. Additionally, the predictive analysis powered by the AI enables the waste management system to forecast the future waste supply and demand, helping to anticipate waste volumes and adjust the process according to ensure the constant feed for energy generation. AI also facilitates the process optimization by continuously analyzing the data from waste to energy facilities, adjusting the parameter like temperature and pressure to maximize energy output and operation efficiency. With real-time monitoring of AI, powered system can track the operation parameter and identify the potential issues before they lead to breakdown, ensuring the timely maintenance and reducing the cost down. AI further support energy demand forecasting and and integration, predicting the energy consumption pattern and allowing the waste-free energy plant to align the energy production with grid needs, thereby improving the renewable energy integration and grid stability. AI ability to monitor and adjust the operational setting also to reducing the environmental impact by minimizing the harmful emission like CO2 and NO2s, ensuring that the process environmentally and comply with the regulation. And AI also increase the economic feasibilities by reducing the operational cost, optimizing the energy production, improving the resource utilization, which makes the energy waste to energy project more financially and scalable. Thus, the technology it transfers the waste management into the more efficient, the cost-effective, and sustainable practices, advancing the goals of smart cities and circular economy. Next, the role of robotic in waste sorting. In smart city, the role of robotics in waste sorting is becoming increasingly essential for achieving and sustainable waste management. Traditionally, manual waste sorting process is labor intensive, error prone, and often inefficient. Especially with the growing complexity of urban waste streams, robotics is powered by AI and machine learning provides a solution that can enhance the speed, accuracy, and overall efficiency of sorting waste for recycling, composting, and disposal. Robotic system in waste sorting can identify and segregate the various material such as plastics, metals, paper, and organic waste based on the property. By using the advanced sensors and cameras and the AI-driven algorithm, robots can quickly classify the sort waste which in high precision. The robots are often equipped with vision system that enable them to see and analyze the material and conveyor belt, making the real-time sorting decision based on the predefined criteria. One of the significant benefits of robot sorting is increased efficiency. Robots can work continuously without tired and faster. They also help to reduce contamination in recycled material, which is common issue in traditional sorting. The use of robots significantly increases the throughout the recycling plants and reduce the human error in sorting, ensuring higher quality and purity of recycling material. It also reduces the labor cost and improve worker safety in hazardous waste sorting environment. Robots are equipped with to handle the dangerous materials such as sharp objects, chemicals, toxic substance, thus minimize the health risk for human worker. Furthermore, robots can adapt to changing the waste systems, allowing for better scalability in cities that experience waste generation patterns due to seasonal changes or pollution growth. The integration of robotics with AI and IoT enables waste sorting system to become more intelligent over time. The system learns from data to improve the sorting and accuracy and adapt to new material and the emerging waste streams. As a result, cities can significantly increase their recycling rates, contributing to circular economy by recover the value materials from waste. Ultimately, robotics play on advancing the waste management system, smart cities, making waste sorting process faster, accurate, and sustainable. Next, we go for smart bin. Is a small level of robotics or easy machine. A smart bin is an advanced waste management solution designed to improve efficiency and sustainability in urban cities. It's fixed with sensors. Smart bins can monitor the waste levels in real time, sending the alert to the waste management system when they're full or nearing the capacity. This functionally helps to optimize the waste collection routes, reducing the number of trips made by the collection trucks and lowering the fuel consumption, thereby decreasing the carbon footprint of waste management operation. By using data analytics, smart bins to provide valuable insight to the waste generation pattern, allowing authorities to schedule the time pickups and adjust the waste management strategies accordingly. Some smart bins also designed to automatically sort the waste, separating recyclable from non-recyclable at the point of disposal. This built-in segregation improves the quality of material sent for recycling and reduce contamination, making recycling process more effectively and efficient. This sorting mechanism helps to cities achieve higher recycling rates and support the circular economy by ensuring that more materials are reused rather than to send to landfill. In addition, smart bins are often equipped with user-friendly features like foot pedals or touchless sensor or promote hygienic waste disposal, further encouraging the public to dispose of waste responsibility. In future, digital display that provides a real-time feedback to user, including reminders on proper waste sorting and recycling practices, engaging the public awareness and participation. Data collected from these bins is valuable for monitoring waste trends, identifying the area of waste generation, and tailoring the waste management services to meet the need of specific neighborhoods. In some cases, smart bins are integrated with a large city-wide waste management system, enabling the coordination between the waste collection and sorting and disposal operation. Ultimately, the smart bins contribute significantly to reducing waste management cost, improving the operational efficiency, and fostering the collection of wastes. A real-time data sharing position them as essential component for smart city, helping cities manage their waste more effectively and work towards cleaner, greener environments. By placing innovative technology like smart bin, cities can engage the waste reduction efforts, improve the recycling rate, and support the more sustainable and urban living. Our technological is inserted, but our public awareness is very, very low. The public awareness and engagement is the main factor success of waste management initiatives, especially in smart cities. Effective waste management system is not only the technology and infrastructure, but also an active participation from the residents and local communities. Building awareness about the importance of waste reduction, recycling, and proper waste disposal can significantly improve the effectiveness of waste management strategies. Educating the public about the environmental impact of waste, such as pollution and resource depletion, encourages individually to adopt more sustainable practices in their daily lives. This includes the simple action like reducing waste, segregating recyclable, composting the organic waste, and avoid the single-use plastics through the various channels such as social media, community workshops, and education camps in schools and colleges, in citizens are informed about the benefits of waste segregation and the importance of supporting the recycling program. Community engagement can also ensuring the compliance with the waste management regulation and promoting responsible behavior, such as reducing illegal dumping and littering. Involving the local communities in the planning and implementation of waste management strategies increases the sense of responsibilities and fosters as a cooperative approach to manage the waste. Community-driven initiatives like neighborhood cleanup the drives or local recycling program can strengthen the collective effort to reduce waste and improve our urban cleanliness. Moreover, smart cities often implement digital tools to apps that allow the residents to track the waste collection schedules, report issues like overflowing bins, and participate in recycling challenges. The technologies make easier to people stay informed, connected, and engaged in the waste management practices. Additionally, the local governments can organize rewards or initiatives program. Rewards are a initiative program to recognize and encourage the households or business that excel in waste reduction or recycling efforts. Overall, raising the public awareness and involving the community in waste management decisions are essential for cultural sustainability. When individuals understand the importance of waste reduction and actively participated in waste management efforts, cities can achieve higher recycling rates and reduce landfill waste and promote environmental healthily, contribute to the cleaner and more sustainable urban environment. Okay, we go for a case study of Singapore waste management. Singapore waste management system is global leader in sustainability, efficiency, and innovation. The city mainly focuses on waste and minimizing through the public awareness campaigns that promoting the reducing, reusing, and recycling. In the city, in the Singapore, waste management strategies include the mandatory waste segregation for household and business, ensuring that recyclable materials are separated from the general waste to prevent contamination and improve the recycling efficiency. Singapore has invested in the state-of-art of recycling facilities that use automated sorting system to process the material like paper, plastics, and metals at high capacity. And also here, you have a different approach to use waste to energy plants, which convert the non-recyclable waste into electricity. We already discussed about how the non-recyclable waste to energy. The significantly reducing landfill waste to while generating the renewable energy. Singapore also committed to achieving net zero concept by 2030. And with the master plan of zero waste master plan, focusing on engaging the recycling rates and promoting the circular economy. Advanced digital technologies such as smart waste bins equipped with the sensor and data analytics for optimizing the collection routes. They contribute to the more efficient waste management. The city also a robust program for managing food and encouraging the recycling donation of surplus food and reducing the food waste through the grants and initiative. Public participation is a key element which program like community recycling ambassador. The community recycling ambassador and they say yes to wasteless. Say yes to wasteless. Campaign and engaging citizen is the responsible waste practices. Public prevent partnership, green building initiatives, and the use of cutting edge technology. Further strengthen the Singapore position as a leader in sustainable waste management. Through these combined efforts, Singapore serves as a model for the other cities seeking to implement the sustainable and efficient waste management system. In Tamil Nadu, Coimbatore is engaged in the prominent example of smart waste management in India. They got a fine also leveraging technology to improve the waste collection, segregation, and recycling effort. The Coimbatore city is implemented with range of smart solutions to tackle the growing waste management. One of the key initiatives is smart bins. And the city's focus community engagement by organizing the campaigns and involving the local resident to waste management and give awareness to segregation of waste in at the home level. With this smart waste management solution, the Coimbatore is advanced towards the becoming a cleaner, greener, and setting benchmark for the urban cities. And also, he produced a local bylaw about the waste management. Next, challenges implementing the smart waste management. One of the primary obstacles is the high initial investment cost. Is high investment costs associated with the smart technology such as sensor, IoT devices, and advanced waste processing facilities. The system requires significant funding for installation, integration, and infrastructure upgrades, which can burden especially for developing cities with limited budgets. Additionally, the cost of training personnel to manage the system and ensuring the long-term financial sustainability and add to the challenge. Another crucial issue, data quality and availability. Smart waste management relies real-time data optimal functioning. However, gaps in the data collection, inaccuracies in sensor reading, or incomplete data sets can hit the decision making and reduce the efficiency of the system. Cities invest in robust data management and analysis tools to overcome the limitation. Similarly, technological challenges such as system integrating compatibility with the existing waste management infrastructure and cybersecurity risk can complicate the implementing process. Ensuring that smart system work increasing the platform requires careful planning and advanced technological expertise. But also your maintenance and technical support poses the another burden. Smart waste management system require regular maintenance of devices such as smart bins, sensor and IoT devices and communication networks. Any breakdown in the system lead to delay in insufficiency in waste collection, ensuring the accessible, reliable technological support and have a skilled workforce to address the technical issues promotingly critical for sustainable operation. Moreover, achieving the public acceptance and behavior change in significant challenge. For smart waste management to succeed, citizens must actively participate in proper waste segregation and disposal practices. Changing after the educational and community engaged efforts. and regulatory and policy barriers. Can also adaptation of smart waste management. Many cities lack clear policies and guidelines. For our Coimbatore area, gave a separate policy bylaw for integrating the smart technology into waste management system, creating a confusion among the stakeholders. In some cases, outdated waste management regulation may not align with the modern smart solution, delaying the approvals and implementation. Government must establish the support regulatory framework and provide an initiative to encourage the private sector participating in smart waste initiatives. The challenges addressing them through the strategic planning and collaboration between the public and private stakeholders and investment in capacity building can improve the successful smart waste management. For overcoming this barrier, cities can unlock the full potential of a smart waste solution, creating the cleaner, more efficient, and sustainable urban development. The future waste management is being shaped by our cutting-edge technology with trends like AI-powered waste sorting, IoT, monitor, robots collection, or smart waste to energy system. AI-powered waste sorting is evolving recycling process by enabling the high-efficient and accurate segregation material. Using advanced machine learning algorithm or deep learning algorithm, AI system can identify the sort of different types of waste. Is already said like plastic, metals, and papers. IoT enable the waste monitoring and another transmission trends also. And we know about the robotic waste collection and we know about the smart waste to energy system. Okay, next we go for the government support of a policy or forming the policy. The policy and the government support play a main role in the success of smart waste management system. The effective waste management system policy set the clear goals, establish the regulations and creative frameworks that guide to the implementation of innovative technology and strategy. Governments can provide financial initiatives, grants, or sustains to encourage the private sector involvement and investment in waste management infrastructure. Policy support also ensures the creation of waste segregation and recycling laws, making it mandatory for industries and households to participate. The government backing is essential for the public awareness campaign that educate the citizen on proper waste disposal and sustainability. A regulation around the waste to energy projects, landfill management, and environmental protection help minimize the pollution and reduce waste volumes. Furthermore, government support enables to establish for monitoring the system to track the waste generation and management effectiveness. The collaboration between the local people and the national authorities ensure the coordinating the approach to waste management challenges. Policies that promote circular economic and principle to help to reliance on landfills and fossil resource recovery. Ultimately, strong government support and policies drive the transition to more sustainable and efficient way to management system. Future vision. We know the future vision of waste-free cities not only the relies the advanced technologies and government policies, but also emphasizes the responsibility of every citizen to contribute to sustainable waste management. In waste-free India, citizens will play a key role to adopting the eco-friendly habits, minimizing the waste generation, and actively participating in efforts to reduce reuse and recycling material. Every individual will be encouraged to make conscious choices such as using reusable bags, avoiding the single-use plastic, and properly segregating the waste at home sources into biodegradable, recyclable, and non-recyclable. In the cities, education and awareness will empower the citizen to understand the importance of waste management. Campaigns and program will teach people how to compost organic waste at home, recycle effectively, and support sustainable practices. Schools, colleges, and workplaces incorporate the lessons on waste reduction and environmental conservation and creating a generation that values sustainability. Our citizens will also take responsibility for keeping their neighborhoods clean by avoiding the littering and participation in community cleanup drives. They will report illegal dumping and support local authorities in enforcing the shared waste management, like neighborhood composting centers or waste collection program, fostering the spirit of the collaboration and responsibility. Support growth initiatives is another critical responsibility of Indian citizens. People will actively use the smart waste management system, such as smart bins and other apps, to report waste-related issues and follow the proper waste disposal guidelines. Citizens will also encourage the local business to adopt the sustainable practices and choose eco-friendly products and services. Through the conscious consumer behavior, individually we reduce the waste by pursuing durable, non-repairable, and recyclable products, embracing the circular economic mindset. They will priority reusing and repurposing items, ensuring that fewer resources are wasted. Communications promote the sustainable festivals and celebrating the minimum waste generated during the public events by optimizing the biodegradable decoration and eco-friendly practices. By collectively embracing the responsibility, Indian citizens can significantly reduce the pressure on landfills, prevent the pollution, and contribute to cleaner cities. The shared effort, combined with the advancements in technology such as AI-powered waste sorting, IoT-enabled waste monitoring, and the waste-to-energy system, will create the sustainable urban spaces. A waste-free India will reflect the value of Swachh Bharat and Mahatma Gandhi vision of cleanliness, wherever every citizen feels accountable for the government, for the environment. Together with the participation of every Indian, waste-free cities will become a reality, setting an example for the world by showing how united effort can lead to cleaner, greener, and more sustainable in future. Any queries? No. Okay. Thank you for giving me this wonderful opportunities to present on such an important and meaningful topic. Thank you.
Thank you so much for your presentation, sir. Dear participants, kindly join the next session at 7:30 p.m. Thank you, sir.
Thank you, brother. Thank you. Thank you.